I'm going to start at the beginning here. I will say I've already put 2 videos out in Teams. Okay, so the first video talks you through up to page 7, just the first couple of things. And the second video gets you up to Pythagoras, I believe. What we haven't got anything after that. So I'm going to prioritize from page 21 onwards in this, but pick out the individual questions that will help you for the mock. But I will start at the beginning and just tell you the important ones, okay? So in terms of transformations, okay, the only one you need for the mock is rotation. So the only one is rotation. Let me get my pen quickly. Is rotation. That's the only one, okay? What you're going to do is find the center of rotation, find the point. So in this case, minus 2, 3. Remember, the first number tells you right or left. The second number tells you up and down. Okay, so minus 2 across, 3 up. You're going to put the tracing paper over this, trace the shape, but also trace that point onto the tracing paper. Put your pen on the point and then turn your tracing paper, in this case, 90 degrees. So you're going to turn it 90 degrees anti-clockwise. That would move this boom, 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 up to here. And then hopefully you'll be able to kind of trace through the paper and see, all right, that's his new position. Right, that's rotation. As I said, I'm going to keep talking, ignore the rest of this. Right, you can try all these other rotation questions. However, it then moves on to translation. Forget about it for today. Right, or forget about it for tomorrow. Reflection, forget about it. Okay, changing the subject of the formula, we only need the intermediate versions. Right, so let's try this one as a good one here. To make M the subject, to leave M by itself. Don't bring M to the left-hand side. M is on the right-hand side and it's positive. It's on the right-hand side and positive. That's totally fine. Leave it where it is. Let's bring the plus 7 over. There's minus 7. Leaving the 6M where it is. And then let's divide by a 6. The only time I would ever move the subject is like here. Make G the subject, but it's negative. At that, there, I'd go, hang on, I don't want those negatives. Maybe I will move that over there. Move the F then in the other direction. So 3G equals 2 minus F. So G is 2 minus F over 3. Okay, that's that. I am rushing, okay? Right, the next topic in here is called changing the subject of the formula higher. It's not in your mock. We will be going back to it. It'll be the first lesson after the mock that we'll go back and fill in all these gaps, okay? It's quite tricky, the higher stuff is. Trial and improvement, again, I don't want to say too much. There'll be one in there. Just get it done. Expanding and simplifying, yeah, it should be okay with single and double brackets. Not a lot to say there either. Volume of a cylinder, just remember that the volume of a cylinder is the area of the circle, right, which is pi times the radius squared, which is here. Once you've got the area of the circle, you times it by the depth. Okay, that should be enough info to get you through that question. Don't worry about mass, density, volume for this paper. Okay, Pythagoras, again, okay, and also trigonometry. Trigonometry using an angle to find a side, but also trigonometry to find a side. I think there's all of them in there. There's a Pythag question. There's also a trig to find an angle and a trig using the angle. Okay, so all of the ones you need to look through your booklet, we've done all these. Okay, what you don't have to worry about in this mock is anything like that, which was quite tricky, but also any of these double triangles. From what my memory, there's nothing like this in there. They're standard single triangle questions. And now we're back to where we were, okay? Oh, sorry, where we need to start this paper. Okay, so the ones that I'm interested in for now are, okay, how do I factorize this? Okay, so I'm looking for 2 numbers, the times to make the end, and the end number is minus 28, that add or take away to make the middle team, yeah? And the middle number is minus 3, important. All right, that is minus 28. I'm not so worried about that, but I am really, really, really worried about that minus 3 there. So 28 is 2 times 14. That won't allow me to make 3. It's 7 times 4. That will. Right, and because it's minus 3, it's not 7 take away 4, it's 4 take away 7. So the important numbers are 4 and take away 7, and they go in there. Now, I've seen this question before. It may then ask you, how can you prove your answer is right? Well, the best way to prove your answer is right is to expand the double brackets and check you go back to where you came from. So x times the second bracket plus 4, if you do it this way. Otherwise, whatever method you use. So x squared minus 7x plus 4x minus 28, giving me x squared minus 3x minus 28. Now, you won't have to actually do that, but one way you can prove that you've done that right is to expand your double brackets and check you go back to where you came from. The other type of factorizing then, okay, is if there's only two terms, in which case it would be a single bracket. All right, what can come out to here? 12 and 3, both in the 3 times table. X times x, x times y, we can take an x out. 3 times what makes 12, that's 4. X times what makes x squared, that's x. Plus in the middle. 3 times what makes 3, 1. Do I need the 1? Maybe, maybe not. The x has come outside, but the y, all right, doesn't matter if we leave the 1. We could have just called that y, but there's no harm leaving 1y there. Okay. Standard form, guys, you've got a calculator. Stick it in your calculator as it is, right? Just using the power button, using brackets, stick it in your calculator. But if it gives your answer as a number, okay, just remember to put that number back into standard form. We mentioned this in school. We said the volume of a cube, it's only a little one marker, it's a show that. They like these little questions, show that. Here's a bit of information, show that this is correct. So what have we given you? We know the length, the width, and the height. So I'm timesing them all to get the volume, length times width times depth or height. But I'm also told that the volume is 132. Like I was like, 1 mark. Oh, I would have thought that's enough for 1 mark. But all you've got to show then is that if you expanded that, if you times both those things in the bracket by 5x, you get that. Boom. This is a nice opportunity then to, I'm wondering, will they ask you to solve that with trial and improvement? Mm-hmm. Maybe. Upper and lower bounds. The one I'm going to go for here. I'm going to have a quick look at this one. Okay. So it says t is 98, but that is correct to the second significant figure. The second significant figure is in the units column. Okay. Tens units. So it's correct to the nearest unit. Therefore, half of a unit is 0.5. So my upper bound for this, I would add 0.5 on, and my lower bound, I would take 0.5 away, okay? And then W is 0.5, so to the first significant figure. So this time, the first significant figure is in the tenths column, okay? So I need to add 0.05 and take away 0.05. So my upper bound here would be 0.55 and my lower bound would be 0.45. Okay, that'll get you a few marks just by writing your upper and lower bounds. It says now calculate y, but more importantly, the word in bold is the least value of y, the lowest y can be. So the lowest y could be, wouldn't be 98 divided by 0.5, right? T divided by W. To get it as low as possible, I'd want that to be at its lower bound and that to be at its upper bound. So we're going to use 97.5 for the top, and then upper bound of 0, so we're using that number there, that lower bound, and we're divided by 0.55, which is the upper bound of that. You put that in your calculator, chaps, and then you've got to give your answer to 1 decimal place. So remember, when dividing, to get the least possible answer, it would be a lower divided by an upper, or to get the greatest possible answer, it would be the opposite, an upper divided by a lower. And it's a division sum that you need to worry about for this mock exam. Okay. Again, there's things we're going to go back to, all these kind of wordy things with other maths involved, but that's okay for now. Okay, the question I'm going to do here, the most similar looking thing here, I'm going to go past this and this. I believe we'll try this one here. Two similar shapes have areas of 700 and 440. So basically, we've got a shape here and a shape here. I don't even know what they are in this because it doesn't matter. The area of the little one is 140. The area of the big one is 700. So my area scale factor, because I'm dividing areas, is that. It would have been lush if I had a calculator on hand. Let me just open one on my phone and see if I can. Because I might actually do this one for you. 700 divided by 400, no, divided by 400, divided by 140 even, is 5. God, I should have done that without doing that. Okay, that's 5, right? The perimeter of the smaller shape is 83 centimeters. Perimeter is a length, right? Perimeter is a length. What is the perimeter of the larger shape? So these are lengths, so I need my length scale factor, okay? The length scale factor is the square root of the area scale factor. Now, you could do this there and put what the answer is. Let me do that, okay? But I would expect a lot of decimal places, at least 3, because it's not my final answer. So to get the missing length, I need to take the 83, and because I'm making it bigger, I need to times it by my length scale factor. But I'm just wondering if it would be more accurate to just put it in like that, to not even bother working it out, maybe. No, either of those I would take. This is going to be more accurate than the top one because the top one has been rounded. Okay, but either way, if it's areas you're dividing, to work out the length scale factor, you need to square root. And if it's a volume scale factor you've worked out, to go back to the length scale factor, you'd need to cube root. Okay. Let me just check, because these videos are timed and I've only got a certain amount of time. Oh, I've still got 3 minutes. Wonderful news. We can keep going. I talk about volume scale factor there, and an example of that would be, no, these are areas as well. So this would be the same sort of thing. But no need. There we are. 2 similar pyramids with volumes. So in this one, because I'm dividing volumes, no. Big one divided by little one, and getting an answer for that. Quite a few decimal places. Then my length scale factor, I need to cube root that answer, not square it. Again, quite a few decimal places. Then the height of the larger pyramid is 25. So if we're talking about pyramids, the larger one has a height of 25. What's the height of that one? So I'd be dividing that by my length scale factor. Okay, I hope that does make sense. We've probably got time for one more in this little bit, then I'll okay. I can't remember these. That's good, isn't it? Right, let's concentrate on surface area because I think that's the most important one here. If I asked you for the surface area of this one, I believe the surface area of a sphere, you will find this in the front of the paper in the formula sheet. So when you see your spheres, your cones, things like that, front of the sheet, which one do they want? They want surface area. It's 4 pi r squared. So it would be 4 times pi times the radius squared. Okay. However, that, whatever that is for a full sphere. I'm just doing this one here. Okay. But because it's a hemisphere, I need to divide that by 2. But then all I'll have then is the area of the curvy bit of the hemisphere, right? If I were wrapping this, I'd also need the area of the top. So once I've got the area of the curvy bit of the hemisphere, which is here, which is half of the total surface area, I then need the top, which is a circle, so it would be pi times the radius squared again. Boom. And then I'll add these together. The area of the curvy bit plus the area of the top. I'm going to stop this video right now and come back with the second part, although I probably will flip them both together, so it'll come over as one video to you. But yeah, what we did there is we looked up just to remind you, we looked up the formula for the surface area of a sphere. We worked it out as if it were a full sphere and then cut it in half because it's only half a sphere. right? And then we realize, but by cutting it in half, we kind of open up. We see this sort of circle appear on top. So we're going to need the area of that circle as well, which is pi times the radius squared. Then we need to add our two answers together to get the total surface area. Okay, the one I'm going to look at here, although the method is the same for all of them. I can't quite remember if it's more like the one at the top here or the one... Oh, I don't know. Let's go for this bottom one here. We did this in class, okay? But the method here to express two algebraic, these are called algebraic fractions, as a single fraction, okay? To bring them together into one fraction. Well, it's kind of like the same thing we would do if we were doing something like there, right? We would end up timesing both those by 5, 15, 10, and timesing both those by 3, 15, 3. Then we would leave the bottom as 15 and we would just take away the tops. It's kind of what we're doing here. We're timesing the both two things by that. So we're timesing that by that. Then we're timesing that by that. And then on the bottom, we're timesing those two things together. So just like 3 times 5. So 2 times 5 on the top there, 1 times 3 on the top there, and 3 times 5. So it kind of makes sense, okay? But this is the way it's written with algebra. So you write the first thing, and you times it by the bottom, or the denominator of the other fraction. There's a minus in the middle. Oh, minuses just make this so much harder. Then we write the second thing, okay? And we times it by the bottom of that fraction. Then we get a nice little ruler, be very accurate. And on the bottom, we times both those things. Notice that the things on the bottom, those bits of algebra on the bottom, I've put them both in brackets. It's just far easier to show that when you're multiplying both things. That's that bit done. What they would call this simplest form would involve expanding these brackets on the top. So 3x times 2x is 6x squared. 3x times 7 is 21x with a plus in the middle. This is the one though, because it's minus. 2x times 3x is 6x squared, but because the 2x is negative, it's a minus times a plus, making that a minus. 2x times 2 is 4x, but again, it's a minus times a plus times a positive number, so that is also negative. They both end up becoming negative, right? The bottom, you don't need to expand the brackets. I'll give you the mark if you do it and you do it accurately, but you don't need to do it because expanding the bottom doesn't really simplify it. Expanding the top brackets allows us to simplify it, allows us to bring these things together, but the bottom, it doesn't really make sense to bother expanding it, okay? But on the top, we've got 6x squared, and we're taking away 6x squared, so they disappear. We've got 21x, and we're taking away 4x, so we're just left with 17x on top. And like I said, the bottom can just stay as two brackets. There's plenty of marks in there, even if you make the odd little mistake with a minus here and there, there's plenty of marks to get. On to probability, okay? Let's go with probability to land on prime numbers, okay? Got to know your prime numbers. Got to know your prime numbers. 1 isn't a prime number. 2 is, 3, 5, 7. A little bit like when you're doing product of primes. Certainly got to know those first 5, right? So here, your prime numbers are there. Here, your prime numbers are there. And here, your prime numbers are there. What is the probability that all three, so this one and this one and this one, all three land on prime numbers? So this one, the probability is 2 out of 4. And is times. All probability combinations, you've got to times them to work out combinations. Okay, this one is 3 out of 5. And this one is 3 out of 6. Get your calculators if you need to. The top is 2 times 3 times 3. And the bottom is 4 times 5 times 6. I've then repeated that. You don't need to simplify that unless it says simplified. I've then repeated it, but looking at even numbers, well, you can do that, right? But then you always get a part B, which is harder, where there's lots of combinations. Okay, so what we said in school with this one is, what is the probability that it's greater than 4? So you could be there going, oh, right, okay, let's start with a 1, with a 3, with a 2, because that's greater than 4. Then let's do a 2 with a 2 with a 5. That's good. And you're just going to be there forever. There are far too many combinations. If ever a part B in this question, you're like, whoa, there's loads of ways to do that. I'll have to do the probability of that one, and that one, and that one, and that one, and that one, right? Do the opposite. Okay, so if you think of greater than 4 is 5, 6, 7, etc., right? That doesn't include 1, 2, 3, and 4, right? So how can I get the 3 spinners added together to either answer 1, 2, 3, or 4? Well, the only options are a 1 on the first spinner, a 1 on the second, and a 1 on the third. That would only add up to 3. That's cool. I could get a 1 on the first spinner, a 1 on the second spinner with a 2. That would be 4, which isn't greater than 4. It is 4. Alternatively, I get a 1 with a 2 with a 1, which would give me a score of 4. Or I could get a 2 with a 1 with a 1, right? So that's why we only need to do these 4 combinations, but it's the opposite of what I wanted. So this combination would be 1 out of, can't remember how many things were on the first spinner. On the first spinner there were 4, 5, 6. That's lovely. Let's just go with that. So on this would be 1 out of 4 times 1 out of 5 times 1 out of 6, which is 1 out of 120. But actually, they'd all be 1 over 120. Okay, because they're all 1 over 4 times 1 over 5 times 1 over 6. So in total, the probability of getting 4 or less is 4 out of 120. There are 4 combinations out of the 120 possible that would do that. Therefore, the probability of getting greater than 4 is everything else, all the other combinations. And if you take 4 away from 120, there are 116 other combinations. So that your part B, you might be looking to work out the combinations that are the opposite of what you need. Okay, trapezium rule. Okay, we'll do this one quickly, but it's going to be a bit of a mess unless I can get a straight. I probably could, but okay. What you've got to do here, the trapezium rule, is the area. You've got to work at the area of this under the curve. Okay, and what they say, then use ordinates, but all ordinates are splits. So in other words, split it at 0, 1, 2, not the best, but it'll do, 3, 4, 5, and then 6, which is there. So what we're going to do is, it's going to take a little while, but I'm not going to do them all, but I'm going to work at the area of these little mini shapes, and then I'll add them all together to get my estimate. Now, A, if I connect the 18 up to the 20, is a trapezium. B, I'm connecting 20 to 20 is a rectangle. C, I'm connecting 20 back to 18, same as A, right? D, I'm connecting 18 down to 16, 14 even, then 14 down to 8, and then 8 down to 0. But F, I'd say, is more like a triangle, okay? So for here, I'd say that A is a trapezium. You don't need to write this. B is a rectangle. This is a trapezium. This is a trapezium. This is a trapezium. And this one here, I can't put T because I've used it, is a triangle. Right? For all of your trapeziums, you use, again, in the formula sheet, you can use half A plus B times H. Okay? So, but think of a trapezium would normally be this way round. Oh, let's delete that and do that. Can I? Yeah. Oh, dear me, it's taking me all the way back to the start. I'm not starting again, so I'm just going to scroll back through. This is why I love live television. Okay, surround you someone. Okay, so a trapezium. Really am going well here. Like I said, I can't restart, or I'll be there till tomorrow morning recording this. So we need that, we need that, we need that. Lovely. This will do. Back to here. Basically, what these trapeziums are, they're trapeziums on the side, where A and B are the top and the bottom, and H is the height, right? So if, for example, I was looking at A, shape A, it would be half, but think of it on its side. So the top is 18, the bottom has a height of 20, but the height of the trapezium is here, which is only 1, right? 18 add 20 is 38. Half of that is 19. 19 times 1, or just stick it in your calculator, chaps, is 19, okay? B is a rectangle, has a height of 20 and a width of 1, so that's 20. C is the same as A, it's the same shape, right? And we keep going, right? D is half. The height of the first line is 18, plus the height of the second line is 14. Again, the actual height of the trapezium on its side is 1. Everything's 1. Okay. They add them together, get 32. Half of 32 is 16. 16 times 1 is 16. And then fine, I'm not even going to do E, but F is a triangle. Okay. So for the triangle, it would just be base, which is 1, times height, which in this case is 8, divided by 2, so that would be 4. So you've got a rectangle, length times width, some triangles, base times height divided by 2, but the most tricky ones are the trapeziums, and at the end, we'd have to add together A, B, C, D, E, and F, and that's the same for all of these, whether they're shaded underneath or not. You're just splitting it up and working out areas. Okay, which brings us on to the things that we haven't done. Okay, we haven't done, and there's no pressure on these, but I'm going to show you the one or two of them that are going to come up, okay? Now, the one that you're going to get is this, right? This is called advanced trigonometry, and it uses stuff from the front. And don't worry if you don't understand this, okay? But you're going to have an example in your exam where you've got not a right angle triangle. So this is trigonometry for non-right angle triangles. So it's not SOHCAHTOA. So in this example here, we've got 3 sides of a triangle, 17, 22, and 20, and we're asked for the angle X, Z, Y. They should have put a roof on the Z, just to show you this is the one I want. I want to work at this angle here, okay? Right. This is something called the cosine rule. We're going to do these after your mock, but just for now, you need to go to the front of your paper and it tells you that A squared equals B squared plus C squared minus 2BC cos A. Okay? Right. Good luck with this. Here we go. In this triangle, right, the angle that you want to find needs to be called capital A. This probably will make no sense. I'm just trying my luck here, okay? Opposite it becomes little a. So the side opposite capital A is little a, right? So the side that, let's say that again, the side that you want to find out in the question, you call it capital A, and then the side opposite it becomes little a. The other 2 sides are little b and little c, but it doesn't matter which way round. So as long as you get capital A in the right place and little a opposite it as the side, B and C don't matter. You then stick your numbers in here. A squared, well, little a is 17. B squared plus C squared minus 2B. Now, some people like to put times in here, times. I like brackets, like when I'm doing trial and improvement. B is 22. In fact, you could even put these in brackets. You know, when we substitute it won't harm. Right. B, C, cos A, and that's what we're trying to find out. So we don't know what that is, okay? So on your calculators then, chaps, we will do, right, to get some more marks on the board, because I'm just all about getting as many marks as we can based on the fact we haven't done this. We can work out what 17 squared is. Right, that's 289. We can work out what 22 squared is, which is 484. Plus, we can work out what, and all I've done is copied this from the front and stuck the numbers in. We can work out what 20 squared is, which we should know is 400. We can do 2 times 22 times 20, which is 880 cos A, right? To leave this bit by itself, I would add those together. I'm just doing this bit by bit. So there's something else that's okay. We can add that to that for a minute. We can't take it into a third little 15 minutes here, so we're slightly over half an hour, but it doesn't matter, right? I don't know where it cut out, right? Just in case I'm sure it's around here. So what we've got then is 289 equals, we can add those together, 884. We can't take the 880 away because it's tagged onto the cos A, it's times in the cos A. It's like 3x. You wouldn't, yeah, it's like a different thing, okay? However, to leave the cos A this bit by itself, the 884 could go over the other side and take away from the other side. Right. I'm coming to a really nasty part here. So let's do 289 take away 884. So minus 595 equals minus 880 cos A. Now there's two ways to think of this, and I don't want to stress you out in any way. Certainly don't look at any other examples bar this, okay? Okay, that minus 880 is times in the cos A. The opposite of times is divide, right? So you could go, and I'm going to give you two options here. You could go minus 595 divided by minus 880. It's not a minus becoming a plus, it's a times becoming a divide equals cos A, right? So now you're taking the times over as a divide. That's one option, right? The other option is, we said earlier when we were changing the subject of the formula, if your subject is negative, take it to the side as positive. So you could flip the sides here so that the minus 880 cos A comes over to be positive 880 cos A, and the minus 595 goes to the right-hand side to be positive. So they flip sides, and both of them flip signs. And then you're dividing a positive by the... Either way, a negative divided by a negative is positive, and a positive divided by a positive is positive, right? So cos A equals 595 divided by 880, right? So again, I don't really want to be rounding this too much because it's not my final answer. 676, maybe an extra, right? But it's not cos A, I want it's A. And remember, it's like trigonometry with like SOHCAHTOA stuff. If ever you're finding an angle, the last step always is to take your sin, cos, or tan over and make them cos minus 1. Okay, so A equals, can I cos minus 1? I'm sure I can. Hang on a second function, because I'm using my calculator. Cos minus 1. Please work. And to one decimal place, I get 47.5 to one decimal place. Okay, you might get 47.4 depending on your rounding of this, but yeah, it's in that ballpark. Okay, so let's look out for another one of these. Right, again, no, I'm looking for the ones where they give me the three sides. There we go. Calculate the size of CAB. The roof is on A. This is the angle I want. Oh, it's quite handy that it's called A, because that's going to become capital A, because it's the one I want to find. C, A, B. So this becomes little a. So get those in position. The other two become B and C. Again, you've got A's copied from the front. Nothing to learn. It's called the cosine rule. That's what you're copying. Okay. Put your numbers in. 23 squared equals 13 squared plus 17 squared minus 2. B, use brackets for these two at least. C, cos A. Right, exactly what we just did. Follow that work method through. Work each one out. Add those two together. Take them over. Try and follow that pattern for that one. Okay. And the final question. Ignore all these. These are other things. Again, we've got to fill in, but it doesn't matter for this exam. The final thing is arcs and sectors. Dare I mention it? Yeah, come on. We have done these. Okay. Remember, the circumference of a circle is pi times the diameter, and the area of a circle is pi times the radius squared, right? However, if you wanted the length of that arc, okay, the length of the arc, you would have to take your circumference, which is all the way around, and times it by the fraction. Well, the fraction of the circle we're talking about here is 42 over 360. Alternatively, if this question asks for the area of what's called a sector, called a sector, and the outside is called an arc. Then you would take the area of the full circle, and again, the fraction of the area you want is that angle over 360. It tells you in the question the radius is 7. So if the radius is 7, which is that, then the diameter would be 14 to use with this one, and the radius would be 7 to use with that one, okay? Right. However, what you haven't been shown or told is what happens if they make it into a triangle. You've still got here your sector, right? But you've got a triangle that they've made it into. Now, in the front of your books, by the cosine rule, which we just said was a squared equals blah, 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 it also tells you that the area is half AB sine C. That is the area, of a triangle which isn't a right angle triangle. So when we're doing Pythagorean trig and anything earlier in the paper, we're using for triangles. Even in the trapezium rule thing, we're using base times height divided by 2, right? But in these last 2 or 3 questions where we've got these non-right angled triangles, that is how we would work at the area of a triangle, okay? However, let's just quickly label a random triangle here, right? In this case, the angle that they give me is big C, and opposite big C is little c. A little bit like when we did the cosine rule, we labelled the angle big A, and opposite big A was little a. And this time around, it doesn't matter which A and B are, as long as little c is opposite angle big C. And this is a question about capital angle capital C, right? Okay. The radius of this circle is 8. Great. The length of the line A to C is 19. That's all the way to C. The length of the line... No, the area of the triangle is 70. Calculate the area of the sector. Right. Let's have a look at this first. I hope this doesn't run out. So what we've got in the from the triangle point of view, the full triangle, okay, so we've got 19 here, 8 here, and we're told that the area is 70. Now, the important angle to me in this question is this one here, which is here. So if we call that capital C, opposite it would be little c, and I appreciate some of you might want to turn off here because this is something I need to show you really. I'm just giving you a fighting chance. And the other 2 sides would become A and B, right? So the area of a triangle is half little a, which is 8, little b, which is 19, sine C, but we don't know the angle C. It would be useful to us, but we are told that the answer, that the area is 70. So a bit like in the cosine rule where we were working backwards to find the angle, we're doing the same here. Here, we can do this bit. We can do half times 8 times 19, right? That bit there, when I put that in my calculator, becomes 76 sine C equals 70. Much like when we just did, we then can take this bit, which is times in the sine C over, as a divide. And to get C, we need to sine minus 1 it. Okay? Again, I could have worked that out and put in a number in there, or I could do it like that. Let's do it, though. Let's do... It's 67 degrees. Bang on. Actually, 67.1, I suppose. Right? But then it says, okay, now you've got this, forget the triangle, what's the area of this sector here, knowing now that this angle here is 67.1 and that the radius is 8, well, the area of the full circle would be pi times the radius squared, and we're told the radius of the circle is 8, we know that it's that there, but the fraction of the circle we want is 67.1 over 360, and that's your final answer, whatever that is. And that concludes the paper, basically, right? Now, that is tough. And if that makes no sense, don't worry about it. I'll mark it, but, in terms of grading and things like that, I won't be taking that into consideration, those last 2 questions. Just do your best for them. And we'll leave that there. Good luck for tomorrow.